So, our indeterminate forms, we are going to have quite a few of them. So, indeterminate forms are ones that we can't evaluate the limit of. If it is 0 over 0, or infinity over infinity, that's what we did yesterday. And we just go straight into L'Hopital's. Okay, but what we just read is that if you have 0 times infinity, that is another indeterminate form. We don't know what 0 times infinity is going to turn into. It depends on if you're approaching 0 faster or infinity faster. So it could be 0, it could be infinity, it could be something in between. So our strategy on these is to rewrite as a quotient. Then we can do L'Hopital's. And so we are going to keep adding different indeterminate forms to our list. So we currently have 3. That if we get any of these forms, we don't automatically know what the answer is. So let's take a look at one. Does everybody have what they need from this? So if I said the limit as x approaches 0 from the right of x natural log x. So x is approaching 0. Natural log of 0 is undefined, right? We talked about the natural log graph a little bit yesterday. Remember, it looks like this. So as you're approaching 0 from the right, where is this graph going? So this is 0 times negative infinity. So we don't automatically know what the answer is. So our strategy is to rewrite this. It has to be mathematically equivalent. So I can't just say like x divided by the natural log of x. Is that the same thing as x times the natural log of x? No. So if you want to move one of them to the bottom, you have to do the reciprocal. Now, would you rather do the reciprocal of x or a natural log?
Natural log.
No, Carson's wrong.
I would rather say 1 over x because we have to remember, if we're going to do L'Hopital's, we have to do the derivative. Do you want to do the derivative of 1 over a natural log x? Probably not. Okay, is this mathematically equivalent to the original?
Yes.
Yes, if you divide by fractions, you flip and multiply. So this is the same. Now, if I'm looking at this, the natural log of 0, that's still approaching negative infinity. 1 over a smaller and smaller positive number is going to infinity. So it's currently infinity over infinity. If it's infinity over infinity, what can we do?
How does 1 over x give me infinity?
Because it's 1 divided by a smaller and smaller number. You have 1 pizza and you start kicking people out. So you have less and less and less people eating it. Alright, so what's the derivative of natural log x?
1 over x.
1 over x. If you need to, you can think that's like x to the negative 1 power. So the derivative would be negative x to the negative 2. Alright, let's simplify this a little bit. So we have 1 over x. Negative x to the negative 2 is negative 1 over x squared. How do you divide fractions?
Skip a multiply.
So that's 1 over x times negative x squared over 1. Negative x. Now, can you plug a 0 into that? Yeah, 0. So we get 0. Alright, so if you have 0 times infinity, you move one of them to the bottom by doing its reciprocal, and then you should be able to do L'Hopital's.
We're doing all 3 types.
Alright, is that one okay? Did you say no?
What's it for now?
Oh, basic now.
Alright, Caitlin. we want to read about So, the next indeterminate form that we have is infinity minus infinity. Now, if you add two big numbers, you know that the answer is a really big number. But if we are subtracting, we don't know. It all depends on, is one increasing faster than the other or not. So, in this form, we want to, again, rewrite it as a quotient so that we can do L'Hopital's. So really the same strategy as with multiplication. It's just a difference in how we get it into a quotient.
So if the indeterminate forms and like 0 over 0 and infinity over infinity are also independent, why can't we just do L'Hopital's like to start if they're all?
So that comes back to where I didn't really prove L'Hopital's for you. It will only lead to the right answer in those cases when it's 0 over 0 or infinity over infinity. It's a good question. All right. Let's look at this one. If I ask you for the limit as x approaches pi over 2 from the left of secant x minus tangent x. All right. Well, we know cosine of pi over 2, so that's like cosine of 90 is 0. So secant is 1 over 0, so it's undefined. So it's either approaching positive or negative infinity, right? Because it's an asymptote there. If you are approaching from the left, that means you're smaller than pi over 2, so you're in the first quadrant. So everything in the first quadrant is positive. Okay, so we have infinity minus tangent of pi over 2 is also
Or undefined.
undefined,
Yeah, that's what I mean.
and it's approaching infinity. So this is infinity minus infinity. Now, I need to somehow write these as a quotient. Do you have any idea what we might want to do?
Can we put it in sine and cosine and then do our reciprocal?
Yes, I think that would be an amazing idea.
I know that's what you wanted me to say.
It
That's what I
is.
was thinking about wanting to do.
So secant is 1 over cosine. Tangent is sine over cosine. Look at us. We don't even have to get a common denominator.
Oh my gosh.
So this is 1 minus sine over cosine. Okay, so sine of pi over 2
It's 1.
is 1, so 1 minus 1 is 0. Cosine of pi over 2 is,
No.
Yeah.
Is it?
Yeah.
Sorry, I wasn't looking, and when you don't immediately verbalize and confirm that I was right, I just think I'm wrong.
oh, what have I done to your confidence?
No, it's just because I'm not looking, so I don't
Okay.
know.
So 0 over 0, which means we can do
L'Hopital.
So we haven't plugged in, so we're still writing our limit, but we put the LH to show we did L'Hopital's. So the derivative of the top, what's the derivative of 1 minus sine?
Negative
Cosine.
Yes.
Yes, negative cosine.
What's the derivative of cosine?
Negative sine x.
Okay.
Oh my gosh.
So-
Tangent.
What's, it is, so you can evaluate cotangent of pi over 2, you can think of it as cosine over sine. What is the cosine of pi over 2?
0,
What's the
I mean-
sine of pi over 2?
1.
And we can evaluate that, right? And get 0. Or if you just did cotangent, square root of the bottom over square root of the top.
Just to
0
Just
over
to
1.
confirm, the cosine is the x.
Mhm.
Okay, that's all I need.
So is that one okay?
Yes.
All right. Let's jump to example 10, I think.
X divided by n. What does that mean?
This is x times the natural log.
Oh, that's an L. Okay.
Yeah, sorry.
It's okay.
So, if I am plugging in, this is x would be infinity times the natural log, infinity over infinity would approximately go to 1. Do we really even know that?
No, but
No. So, this was probably
what really, really huge number divided by a not so really, really huge number.
Yeah, so you're still getting something very close to 1.
But
Would
what
you
if
guys
it's
agree?
that much huge?
I think
Like
it's
that much
1.
bigger?
Because-
No, I believe Miss Speckled.
Okay, well, we can work it out.
What if it's that much bigger?
No, I don't want to do more work.
So if we do the
She's
limit
doing it.
as you approach
Why would you say something like this?
My bad.
Okay, but sorry, as long as learning.
Sorry.
Okay, we know it's mathematically equivalent if we divide by the highest powers of x.
One
Sorry
over
for
1.
challenging
It says
you.
1 over 1.
minus 1 over x over 1 plus 1 over x.
Oh my gosh.
So that's a natural log of 1 minus 0 over 1 plus 0.
Sorry.
What's the natural log of 1?
Yes.
0. So it's currently infinity times 0.
I like how you
Okay, I'm
sparked
sorry.
over.
I didn't really mean to. What?
It's currently infinity times.
It's currently 3 times 0. We're not doing any more math.
I'm done with it.
You guys read hostility into things where it was not intended.
It was definitely intended. I
No,
watched
it
it
wasn't.
happen.
I was just working out a problem. Okay. So it's currently 0 times infinity. That is an indeterminate form. So we have to change this into a quotient. So our options. Do you want to move this natural log
No.
to the bottom?
Yes.
You want to do 1
No.
over the natural log of that? You can do quotient rule and
No.
change the whole quotient
Ignore
rule.
her. Don't listen.
Okay.
No, I think we'll do it. Widen our spectrum.
You guys go ahead. We'll see who gets there first.
No, I want to follow Miss Speckled.
Personally, would take that challenge.
You know what?
How would I move the x to the bottom?
1 over x times is fine.
Okay. So the top is approaching 0. 1 over infinity is approaching 0. So now it is 0 over 0, which means
I want to see how funnily I can say it.
Oh.
all right. How do you do a derivative of a natural log?
Do it and then times the argument.
This one is ugly enough as it is. Times derivative of the inside.
Oh my god.
So what do we have to do for derivative of the inside?
Quotient rule.
Quotient rule. Low,
Oh my gosh.
be high, minus high, be low, over low, squared. Over, what's the derivative of 1 over x? So 1 over x is like x to the negative 1.
Negative x,
Oh my
negative
gosh.
2.
We need to do a lot of cleanup here.
Wait. How did we get to negative x to negative 2? Oh.
1 over x is x to the negative 1 power.
Clean.
Okay, 1 over a fraction. Can we agree that we just flip this and make it x plus 1 over x minus 1? Because it's 1 times the reciprocal.
Whoa.
Oh.
Hang on. No,
Yeah.
back. Explain.
Because it's like
If you want to divide a fraction, so if you have 1 divided by this, that's 1 times the reciprocal. So you flip it.
Oh, okay.
Oh, so we
Yes.
just
Yes.
flipped it.
I didn't think that you flipped it, and I was
Oh,
just
no.
confused.
All right. So this turns into that times. Okay. If I multiply this out, we get x plus 1 minus x plus 1.
2.
Can we cancel out that x plus 1?
And negative x to the negative 2 is negative 1 over x squared. So some simplifying. These x's cancel. You can cancel one of these x plus 1's. So what we have now,
Where did our x plus 1 go?
okay,
Oh, yeah, my bad. My God.
so
It doesn't even listen.
1 plus 1
It's 2.
Oh my
Is
gosh,
2.
and we're gonna multiply that by the reciprocal.
over x minus 1, x plus 1. To divide by negative 1 over x squared, you take it times the reciprocal. So if I multiply this all out at the limit as x approaches infinity, negative 2x squared over, can I go ahead and just FOIL the bottom?
Oh,
X squared minus 1.
Oh my gosh, it works out.
Does it?
I don't know.
I
We
don't
have to
know
do
anymore.
the infinity rule, right? I ran out of space on my paper, so I'm really trying to cut corners here.
Alright, so if you put this in,
Okay, great.
Oh, it was Judy.
so we're getting a negative 2 times a really big number, so negative infinity on top over infinity. Do we know what that goes to?
No.
No, so we have 2 options.
Do it again.
No.
We can do L'Hopital's again, or what's the other way?
With the 1 over x
Yeah.
squared.
When we were finding horizontal asymptotes, didn't we, and I did it up here, take top and bottom times 1 over the highest power of x?
Yeah.
Oh.
So you could still certainly use that, and in this case it might be faster because you'll have to do L'Hopital's twice, although it won't be very ugly this time. Or you could take it times 1 over x squared on top and bottom, so 2 different options.
How do we know when to do it again? And then
If it's still an indeterminate form.
But like, how do we know if like if we're supposed to do L'Hopital again or like?
Well, if you
But
don't get anything
technically
out
you
of
could
this.
do either.
You could do L'Hopital's
But if it's a
until you die.
polynomial over a polynomial, you could do 1 over the highest power of x.
Oh, I'm freaking dumb. I think it becomes negative.
Let's try both on this.
Negative 2 over 1 minus 0. So negative 2.
Why did your trash bags get so translucent?
I don't know.
I want
Cheaper trash bags.
I want the
guess.
better trash bags.
Yeah, those are cheap.
Yeah. Don't put anything heavy in it.
We're put a dumbbell in there. Ruin the custodian's day.
No, I'm gonna put a knife in there.
What?
What?
I'm gonna steal Caddy's knife that she uses to cut up her apples and stab people.
Alright. Is this one okay?
Only if you were to work it out with us, yes.
I could have done that. Maybe by myself.
Wow.
The natural log was a little bit ugly, but if you're not
No.
skipping steps and showing your work, I think it'll be okay. Let's try to get through a couple more
You sound
examples.
super colorful.
When I
I
said
think-
maybe, she's judging you and your coughing.
Okay, if I'm looking at this one, if I put in 0, 1 over 0, 1 over a smaller and smaller number is going to infinity. Sine of 0 is 0, so it's again 1 over a smaller and smaller number. So this is currently infinity minus infinity.
So
Can we do that?
we don't care if it's undefined anymore, we just assume that it's gonna go to infinity.
Well, we know 1
'Cause
over x has an asymptote.
Like the x is approaching 0
Yeah.
from both
Um,
sides.
Why?
Because remember, limits don't care what happens at the point, just as we're getting closer to it.
Wow,
When does the infinity become? Like, at what point will we get a negative infinity?
So
Is that when
technically
it's
this
approaching
one,
from a side?
yeah. And really, I probably should have put a side on this problem because it would be different from each side. It's,
I just am still confused on the homework about how I needed a negative infinity and negative 1.
I can take a look at it and see. All right. So what do we have to do here?
Get a common denominator. Yeah.
So this one has x, so it needs
Sine.
sine x on top and bottom. This one has sine x, so it gets multiplied by x. So that gives me sine x, rect sine x, minus x, rect sine x. So the denominators are the same, we can put them together.
Wow.
So it's x, so sine x minus x, rect times sine x.
Sine 0.
Why would it go like 2 sin x?
0 times
Why
x.
would- why
is
Like,
0.
why would it be 2 sin x? Why is it? Why is x just like in front like that?
Because we're subtracting, we're not multiplying. Sometimes
When you add and subtract, the denominator doesn't change.
it's like 1/2 plus 1/2 is equal to 1. Or like 1/4
Like
plus-
I'm meaning like when we multiply the x
Talking
and
about the
sine
bottom.
x, why is the x out? in
'Cause
front?
you're
Why
not-
Why is it not 2 sin x?
Because,
That's not 2 sines.
yeah,
Mm.
x, so sine x, sine is just an operation on the x, so anything you multiply with it just goes in front. So if I put in 0, this is 0 minus 0, just 0. On the bottom, 0 times 0 is 0. So 0 over 0 tells me, alright, derivative of sine
Cosine.
Cosine.
minus derivative of x. What do we have to do on the bottom?
Product rule.
Oh, we have to do
Derivative of
product
the
rule.
first.
No.
Times the second plus the first derivative of the second. Derivative of sine is
Cosine.
so we have another x approaches 0. Cosine x minus 1 or sine x plus x cosine x. Alright, initially this doesn't look better. Let's see. So if you did cosine of 0 is 1 minus 1 is 0. On the bottom we have 0 plus 0 times 1, so it's still 0 over 0. So what does that tell me?
Love again. Oh yeah.
Why are they the same person back there?
Okay.
What do you mean?
Derivative of
No.
cosine.
Negative sign.
Zero.
Derivative of 1 is 0, so I can drop that. On the bottom, derivative of sine. What do I have to do for this? Yes.
Oh man.
So plus
Oh.
derivative of the first times the second plus the first derivative of the second. Derivative of cosine is negative sine. Alright.
Sinus.
Negative sine over cosine x plus cosine x would be,
1 plus 1.
2 cosine x.
0.
and then x times negative sine x is negative x sine x.
Over.
So, if I plug in
0.
sine of 0 is 0 over 2 cosine of 0 is 1
Oh, well,
minus 0 times 0.
Needs a
So,
second, please.
We get 0 over 2, which we can evaluate.
It's 0. That was so much work to get to. I like how you know what number you're gonna end up with. You're gonna end up with a 1, a 0, or a negative 1 maybe.
Last one we got negative 2.
Oh, we did because I don't remember why. But we had a limit. We had a natural limit.
Yeah,
You have
number one on
science.
the homework, we got 8/5.
So I do remember getting it.
Okay.
Oh, got you there.
Let's try final
Yowzers.
problem for today.
Sure got you.
Oh, this is the one I didn't want you to pick.
Alright, so if I'm plugging in a positive infinity, a square root of a really big number is still a really big number minus a really big number. So, what do we have to do?
Infinity.
Get it into becoming together.
Get it to become
Close.
close. This is
Oh,
what I
man.
mean.
Now we have to find
Okay.
a common denominator.
Alright,
What the flip? Oh wait, it has a common denominator.
Carson.
Oh, there.
So, as we are approaching infinity, I need these to go together as a fraction. Currently, that's not really helping me, is it? Neither one is a fraction, so saying common denominator isn't going to get me anywhere. So what we could do is multiply by the conjugate on top and bottom.
Oh man.
So it's square root of x squared plus 3x with a plus x on top and bottom. Right, so on the top, if you FOIL, when you take a square root times itself, what happens?
It becomes the same thing as it was in the inside.
Because they're conjugates, the outside and the inside cancel. And then negative x times positive x is negative x squared.
Wow, this actually doesn't look too bad.
So we get 3x over the square root x squared plus 3x plus x. So, if I plug in infinity now,
Oh.
3 times infinity is infinity, over
Over
square root of infinity is infinity, plus infinity is
infinity.
infinity. Okay, so we want to try L'Hopital's from here? Let's go for it.
Why can't you do like whatever has power?
You can.
Oh,
Oh.
wait, I want to go back.
No.
Does it
Too
take
far
you-
in,
Does it
huh?
take you anywhere?
Yeah, we'll get the same answer both ways.
Which one
I
is
want to
shorter?
go back.
1 over the highest power of x is shorter.
I wanna go
See
back.
that
Yeah,
one?
yeah,
Daddy was cooking.
So
Okay.
I was cooking, but I don't want. Or no, you can.
So,
Yeah,
can,
no.
we can multiply by 1 over x on top of that.
What's the,
Now, when we do that, 3x divided by x is 3. Okay, let's just hold off on the square root for a second. So
why
I,
would it be x squared?
because it's under a square root, the square root of x squared is x. Plus x times 1 over x is 1. So this is where I'm at currently, right? But I need to bring this x under the square root. So, we did these before.
Can we get the square root of x
Is
squared?
x is the same as the square root of x squared. Do we agree with that? Then, since they're both under a square root, we can divide them. So x squared divided by x squared is 1. 3x divided by x squared is 3 over x. So then we have 3 over the square root. 1 plus 3 over infinity is going to 0. Plus 1.
3 halves.
That's our answer. So L'Hopital's is a tool, but it's not the only option. We've done some of these indeterminate forms in the past. You can still use any technique that we had then.
So, how did the, bringing the x down to the fraction work? Not the fraction,
Into the radical. So we had this. And I said, okay, well that is mathematically the same. X is the same as the square root of x squared. And then if they're both under a radical, you can divide them.
okay.
Anything else? So, that's the end of today's part. Tomorrow we'll talk about the last type, and then we will probably spend Thursday kind of practicing all the types again. So, today